So here are the 15 examples. I tried to choose them so that they had gave you basically an idea of how generic, how universal the ideas both of the theory of constraints and lean in particular are, and how they can be applied if they are adapted, applied to nearly any kind of operation. Okay, and of course we tried to give a wide range of industries, and we spoke about the ones where we can communicate. So we've taken out the stuff that's military and all this sort of stuff. Okay, so off we go. The first one, as you can see, is from the Safran Group, a large, nearly 100,000 employee aircraft component manufacturer, going from engines to, and in this case, flight control systems. So this is the story of a factory of 400 people that made the flight control systems, which are the little things that control the plane to make it go up or down or port to starboard and all that sort of stuff. So rather important. Lots of security and redundant systems and stuff. They called us in because they had a chronic problem of due date performance that was initially around 50%. And as the level of performance within the aeronautical industry was going up from year to year, well, this got to become completely unacceptable, and the Airbuses and Dassaults and others of this world were getting more and more upset, and there was a real risk of them losing their business and the plant having to shut down. The plant manager, the new plant manager, had read the goal a couple of years previously, and in fact implemented the goal in Mexico just before he got this job of being the plant manager of this factory. And so he was already converted or believed in the theory of constraints, and so the theory of constraints was applied to this factory, and it was a bit like the goal. We had to save the factory because the performance was so bad it was going to lose its business and close. So off we went. The first thing we had to do, of course, was to identify the bottleneck, and we did this not by looking at the ERP system, but by wandering around the factory and looking for the biggest queue. It quickly emerged that the biggest queue was in front of quality control. Okay, and watch out, you'll see it in a few of the other cases. It is surprising today how often we get capacity bottlenecks in organizations around quality control, whether it's here in aeronautical business or in pharmaceuticals or even in the food business and elsewhere. Okay, and a bad bottleneck is not a good place to have a constraint, but that was the starting situation. Okay. The other thing was that this factory was just flooded in work in progress. There was stuff everywhere, right? These things are fairly small, so you could pile in a lot of work in progress into the factory, and they had 9 months of inventory and therefore 9 months of lead time on the shop floor, and we had to reduce this, of course. Okay. So we also implemented a rule that we use quite often, at least 3/4 of the time, a rule called 2 for 1, which is very simple. There's too much stuff in the factory. To reduce the amount in the factory, there has to be more coming out than going in. So you are only allowed to launch one thing into the factory when you have shipped 2 things out of the factory. And we used work orders as the unit, so they had to finish 2 work orders to be able to start a new work order. If you want more details about that, you can see a specific video about the 2 for 1 rule, which we recommend if you have a lot of work in progress and you don't know how to get rid of it. Okay, so we do that very often. Anyway, so we did that, having identified the bottleneck, applying the theory of constraints. We exploited it better. As I say, we all focused on these 15 people within the 400 people of the factory, asked them how we could improve their performance, and in this way we managed to significantly improve the output. In fact, it nearly doubled in the first few weeks as we cleared up the stuff. Anyway, it was its capacity was opened up to an extent where it was no longer the bottleneck, and things started to flow rapidly through the system. Okay, and the results you can see are a significant drop in inventory, the due date performance coming back on par. It was around 50% or below 50%. In fact, it got up to 85%. The 15% left of non-performance was essentially due to quality, right? So what we've done was clean up the flow management and this led to the emergence of quality as the main cause in the Pareto of overdue orders. Okay, and by the way, that since then, this is a story that goes back a few years. That's been dealt with also. But that's what we happened in the first few months. And well, the inventory just vanished more or less. And in fact, they're now working on a project to make certain parts in 24 hours, right? So they started with 9 months of lead time, and their ambition right now that they're working on is to do products in 24 hours. And so this great success story led to them winning the group award in the Saffron Group in 2016 for the best innovation and performance, and lots of other good things, and the factory was indeed saved. Okay. The second example is from a very large industrial company with over 300,000 people, and this is just one of its factories. It's engineering to order and make to order of gearboxes, but big gearboxes, the size of larger than a car and slightly smaller than a bus. These gearboxes go between, for instance, a gas turbine and an electric generator in a power station. So we're talking about gearboxes that cost 50,000 to 500,000 euro. They're made. There are no two gearboxes the same, so we're basically talking about one at a time manufacturing, no repetition. A big batch for them was 3 identical units, but it was very rare. And these things are, an engineer's dream. They have to go around at 20,000 RPM for 25 years and not wear down or not break down, of course, and all this sort of thing. Anyway, that was a product. The analysis of the company quite simply showed that the bottleneck of the company was in the design office, the people who designed these gearboxes, since all of them had to be designed specifically for a given application. And in this, so we had a look at this bottleneck, this department with 15 people, and it became fairly obvious that it was a madhouse being killed by multitasking. We actually measured it, as we quite often measure it just to underline to what extent it's got out of control. And the people in this design office were changing tasks at least 50 to 60 times a day. That's to say that they were spending between 5 and 7 minutes on a given task before switching to something else, right? Which, if you can imagine trying to design these complex products with tight tolerances and complex bill of materials and all that stuff, is just not a good way to work, right? And it was leading to a lot of inefficiency, a lot of quality problems, and a very poor working environment. Quality of life was poor. People had been leaving. It was bad, okay? But quite often design offices that are working on portfolios get into that state. Anyway, so that was the starting point, and we wanted to clear it up. We implemented something called start finishing and stop starting, or stop starting and start finishing, which was the orders kept coming in, but we forbid the design office to start on them. They had to finish the designs that were already in the system, okay? And since they had 50 weeks of design work in there, and they started working on the stuff that was nearly finished, in fact, in doing this, on getting them to force themselves to finish work before starting something new, for a few weeks, they actually multiplied by over 6 the output of the design office. Anyway, as things cleared up and work in progress went down, multitasking dropped, and the average a few months later was a tripling, times 3, increase in the throughput and the productivity of this bottleneck, and it reduced the lead times, which were initially 50 weeks, 50, to 8 weeks. And right now they're working on 6 weeks and expecting to hit 6 weeks soon and go even further down. Okay, so that's what they did, and there was lots of other good stuff that happened. We worked also on the factory, on the manufacturing of these parts. We worked on the supply chain, because as they speeded it up, they found that they had some suppliers that couldn't keep up as their lead time shrank, and they were going much faster. And well, there we are. And this was that much more impressive that this organization was heavily dependent on the oil and gas industry. And at the time when we had been, that was a very depressed market, and so once again the factory was had already done some unemployment and headcount reduction before we started this, but boosting the performance as they did meant that they got back onto an even keel, and they started growing again, and everything's fine now, even though several of their competitors have gone bankrupt since. The next one. The next one are the guys who invented ball bearings, another large company, and a channel manager, as they call them, or an autonomous production unit manager, came to one of our training courses that we regularly run, and went off back to his factory and decided to implement the theory of constraints in his part of the factory. And then I didn't know this, he called me back up about a year later and said, well, you come and have a look and tell me what you think. Have I got it right? Am I missing anything and stuff? And it was just a beautiful result, a beautiful implementation. The due date performance had indeed been cleaned up. In fact, when I went to see him, they were celebrating the fact that for 26 weeks they had not had a single order late. Okay, so they basically got to 100.00 on-time performance. It didn't stay at that level because, for instance, it's maybe not the only organization that has that kind of problem. New products were developed that were not so easy to manufacture, which led to quality problems and stuff. So they then stabilized at around 96% due date performance, and then improved from there. But that was the results that they were looking for. They reduced inventory by nearly 50%, 46%, and there was also an increase in productivity of the line of 24%. Right? I put this case in just to show that this wasn't Marris Consulting, right? This is just somebody who implemented theory of constraints. So I wanted just to show that it can be easy, and you can do it just by applying the ideas. So there's nothing. It's not rocket science, right? That's why I put this case in. Right? This is somebody who just understood what needed to be done, implemented drum buffer rope and all that stuff, and those were the results. Okay. Change of scenery. This is the world leader in fast food, very big company, nearly 1 million employees worldwide, and they have implemented a new system for their restaurants in which the food is made for the person once it is ordered. It's not made on forecasts or made before the client arrives. It's when the client orders it that they start making it, okay, to ensure that the food is good and fresh. When this model was rolled out in France, for instance, where we started working, the problem was that the service times had increased significantly and the profitability had dropped with this new model. And so the question that was asked was, can we get back to good levels of speed of service? Can we get back to being a fast food organization and improve the profitability? Okay. So we did a diagnostic. This was one long day from 8 o'clock in the morning to midnight in a chosen pilot restaurant. And we, following that, wrote up an action plan with 13 different points in it. I won't have time to describe them all. The first one was we discovered that they were also suffering from a bad bottleneck. That's to say, the capacity constraint in the system was in fact the point where they assembled the orders for the clients who had ordered a hamburger, a fry, or whatever, and they had to bring all that stuff together, put it on a tray, and serve the client. And it was that operation that was in fact the capacity bottleneck, and it was very chaotic, and it led to many mistakes in order fulfillment and all that sort of stuff. So to avoid that assembly altogether, what we implemented was full kitting right from the kitchen. That's to say, we reorganized things so that the kitchen would in fact produce client order by client order all together, and therefore you didn't have to reassemble it. In fact, the client order became a single unit throughout the management system from the word go, and so that then eliminated, of course, the bottleneck of assembly, since there was no longer assembly to be done. And we also had to do things such as stop some of the key performance indicators. There was one which said you have to start on a client order as quickly as possible, right? And that was followed by headquarters, corporate and stuff. Usual, maybe simple logic. The faster you start, the earlier you start, the faster you'll finish. The problem is that this led to the kitchen filling up with all sorts of things, and so we changed that. And they would only start on a new order in the kitchen when the kitchen had excess capacity or free capacity, enabling it to take care of that order, right? So the work was pulled into the kitchen rather than pushed into it, and that was also a significant point. We also worked on the scheduling of the cooking of the meat and the fries, and did a number of things with regards to the briefs and debriefs of the rush hours and a number of other things. So anyway, and the result of all that was a 60%, over 60% reduction in the service times, and lots of other things. Just two rather remarkable ones. The customer returns were divided by 7, because basically they were no longer had made any mistakes, which was the main complaint from customers. You forgot my hamburger. And the other one was that material losses were divided by 10, because this sort of pull system ensured there was no longer any overproduction. Okay, so that's another story that gives some very nice results. Change of scenery. This is Embraer, and they're world leader in business jets now. Although they started fairly recently, they're a very successful story. And they implemented critical chain on the maintenance of their jets. I'm not going to have the opportunity to describe how critical chain works. There are other videos and stuff where we'll do that, so you'll just have to, if I intrigue you with what critical chain is, have a look and you'll see it's quite simple. Anyway, they implemented this different way of managing projects and operations called critical chain. And not only, they also did a number of other improvements, but the guideline, the main decision was to implement critical chain. And as a result, the times they took to do their operations shrank by 50%. It was divided by 2. For instance, a check C, or a 96-month check, which used to take 10 weeks, took 5 weeks, and all the other kinds of large operations of maintenance were also divided by 2. Okay. The other very surprising and rather nice thing was that the labor productivity of all the mechanics increased by 45% simultaneously, okay, which obviously had a very big impact on the financial performance of the organization. Okay, as I say, not just critical chain, there was better sequencing of tasks. People did focus on the critical chain sequence, and once again we implemented an equivalent of stop starting and start finishing. That's to say, first plane would be finished before trying to bring a new one in, so that people could concentrate on one plane at a time, or a couple of 3 planes at a time in this case, and limit significantly multitasking and changes in priority and all that stuff. Okay. Change of scenery, change of country. This is in the disunited kingdom. This venerable pharmaceutical drug company had misjudged the impact of generics on one of its key products. Its iconic product. It had assumed that since there were generics that cost a quarter of their product coming out, the demand for their product would drop substantially, and they'd overestimated that drop in demand. And as a result, having closed the different production lines, or many of them, they ended up completely overworked on the production lines that were remaining for that product. And so they wanted to improve the output as quickly as possible. It was costing them a lot of money. In this particular case, we didn't really use the theory of constraints, and that's why I put it here, just to show that in some cases the theory of constraints isn't going to help you that much. The OEE, the percentage of the time these machines were running, was less than 20% when we started. Okay, and so basically there were so many downtimes due to machines breaking down, micro stoppages, quality problems and stuff, that it was very much a stop and start organization when we started. There were 4 lines in the system, and you'd be lucky if one of them was working at any one time. So if you took photos, a number of photos, you'd keep saying the bottleneck was there, the bottleneck was there, it was all over the place. Okay? And so we had to stabilize the system, and we basically used more things from the lean toolbox to do that. And in fact, probably the key thing that really brought all the difference was we got the maintenance people and the production people to work hand in hand solving the problems and get rid of all the downtimes and production problems linked to the equipment itself by close collaboration between the production people and maintenance. Okay. And well, we did do one unusual thing maybe, because like many of the lines of the sort, one of the wasted times is changeovers, when you change over from one product to another. Even though this line was dedicated to one product, there were different sizes, different flavors, different whatever, and so they did change the line regularly. And this took a lot of time, and we in fact used the logical thinking process and the goal tree to work on reducing the process setup time, and had a lot of success with that. Change of scenery once again. This go down to South Africa. Aerosud, 700 people in South Africa. Already a company converted to theory constraints. It had been using theory constraints for many years before I met them, in production in particular, with very good performance. And they had previously unsuccessfully tried to implement critical chain in their product development, but they asked us to try again. And so we implemented critical chain on new product development. And well, to go to the punchline, within 2.5 years, right, it wasn't immediate, but within 2.5 years, they got to a stage where they were finishing their new product development in 98.7% of the time on time, right? Which I don't know, I haven't got any other figures to say. Certainly in my experience, that's a world record, and by quite a long way, right? And this is the real world, right? Their clients are Boeing, are Airbus, and so forth, right? Clients do change their mind at the very last moment and all that stuff. They're in the real world, and yet they get this unbelievable performance of finishing nearly all their new product developments on time, right? That's why I wanted to talk about it. And for those who know a little critical chain, if you look at that fever chart, you can see that we are in the real world, right? It wasn't an easy life. Some of those zigzags show that they had quite a few problems that they had to solve, but they solved them. They also, of course, managed the flow through the system better, watching out and managing capacity constraints in their portfolio, and all the classics of critical chain. They now love critical chain so much that they've decided to implement it on any project that they would run. And so, for instance, since they've implemented on a new version of an ERP that had to be implemented, they've used critical chain when they built a new building, and so forth and so forth. So any project now is run with critical chain, and well, they got converted to it, and you can see the results like that. Who wouldn't be? Next example, luxury industry, world leader in luxury goods, and they very high performance company, very huge growth and very good financial results. Wanted to implement the critical chain in their product development, because this part of their business was in fact turning itself in from a product or production factory into a design factory. As I say, they were making a lot of products designed to order for a particular client who'd say, I want it just like this, I want this added, I want that, and so forth. And that plus the renewal of all the different products that was getting faster and faster year by year meant that the key challenge was no longer producing the things, it was actually managing all the designs, the hundreds of designs a year that they had to manage. And so we did a quick analysis. Very quickly it appeared that they had a bad bottleneck. What do I mean by bad? A regrettable one which when you see it you say, oh, that's silly, let's get rid of it. In an organization of over 300 people, just one person whose job was to create the bill of materials. And when we went to look, there was a huge pile of work waiting in front of this person. That was the bottleneck. In fact, we started implementing critical chain after the summer holidays. The diagnostic was just before the summer holidays. So we came back 6 weeks later, and of course they dealt with that and got rid of that bottleneck. And in fact, we went through several iterations of identifying the bottleneck, opening it up, getting to the next bottleneck and stuff, with the result that the overall flow and productivity was tripled in this organization as they did that. Okay, so that's, for those who don't know it, the 5 focusing steps, except it's in accelerated mode. We do 1, identify; 2, better exploit; and 5, we switch because the bottleneck's gone somewhere else, and so we go back to 1. Okay, 1, 2, 5, 1, 2, 5. We do that quite often. It's sort of high speed, getting rid of all the bad bottlenecks. And so that's it. And of course, the WIP production was minus 60% in 4 weeks, minus 80% in 23 weeks. The overall throughput and productivity is way above 150% right now, and it continues to improve year by year. They are a remarkable company. This one is it's not far away from the other factory, both in northern Paris. This one is in Les Mureaux, obviously, which in France is where the rocket industry is all based. In 2017, the production of the Ariane 5 rocket, right, this is before Ariane 6, at the end of the life of Ariane 5, orders were going up for Ariane 5, and they had to ramp up production from 6 tanks. They make the tanks for the Ariane rocket, right, the big cannon in the middle, from 6 a year to 8 per year, and that was their challenge. We had a look, and the bottleneck here was their welding machine. I can't show you a photo of that welding machine because it's unique in the world. It's their competitive edge, because indeed it must weld together that tank, which is 5 meters in diameter, very thin aluminium, and of course those welds have to be perfect, and so it's very high-tech welding, right? More precisely, the production operation was to weld. You welded circularly as you put the different units together, and then you inspected it with X-rays. Okay, so you produced, you welded, and then you did an X-ray, and the X-ray was done by the quality department. And so the utilization of this welding machine was production, quality, production, quality, production, quality, and they were wasting a lot of time switching from one organization to the other. So we implemented a mascot. That's that thing you can see down there, that little very simple thing that was carried around from wherever the bottleneck was. That's to say, it was either next to the welding machine when it was being welded on, and when the test, when they were looking and interpreting the results of the X-rays, which was a bit further down in that same building. That sign would travel over there, so that people knew wherever they saw the sign, please do not interrupt, this is the bottleneck operation. Okay. That and a few other things led to them meeting their target, 25% increase, so hitting 8. And they, by the way, also did successive bottleneck elimination. You can have a video, you have a look at the video there, a very good video by Christine Geoffrey that summarizes the entire thing in 40 minutes. Okay. This next one I particularly like. It's back, in fact, to the first factory I showed, part of the Safran group. We'd implemented the theory constraints in production. We'd implemented critical chain in the product and in the development and industrialization in that factory. And sitting in the back of one of our classes when we were teaching critical chain, there was the maintenance manager. Because I didn't know at the time, but he considered he had a project to run too, and so he wondered if he could use critical chain. And so, well, he did. Basically, he decided to use critical chain for his project. His project was to move 45 of the 57 machines of the factory to different locations, because since we'd reduced the work in progress so significantly in the factory, right, and since, like many factories, machines have basically been installed where there was room at the time when we bought them, and there was a sort of spaghetti mess of flow in the system. Now the factory was looking a lot healthier, and you can actually see the machines again, and there was space. They decided they should move the machines more intelligently and bring them together to form a family of products and all that sort of stuff, right? Things that are fairly obvious in operational excellence. Anyway, so they had to do this. And he did a first plan, traditional way, and he estimated it would take 8 weeks. He went to his boss. The boss said, I can't close my factory for 8 weeks. So he came back and said, can I do it to 4 weeks? And he said, no, I can't do that. There was a long discussion. And little by little, it got to the stage where he had a plan where he could do it in 2 weeks. This didn't just come out, like that. He had a look each time, how could I go faster? So they increased the number of cherry pickers so they could do more wiring simultaneously. He did that, did this and did that. And he got to a forecasted duration of 2 weeks, and his boss said, yes, let's do it, off you go. You can do it week 50 and 51. What? Yes, 50 and 51, that's to say with Christmas in the middle of 1 week and New Year in the middle of the other. So you've got 8 days left. Anyway, off he went, and he did it. He actually managed to move 45 of basically moved nearly all the machines in the factory in 6.5 days. They finished 1.5 days early. Okay. Have a look at the video. You won't believe me because I'm a horrible consultant, but have a look at the video done by the people from Safran. People don't often exceed my expectations, but if somebody told me you could change over all those 45 machines in 6.5 days, I would never have believed it. But, they did it. Beautiful story. This one is here for a different reason. This is the French railways, or the Domaine du Matériel. It's the 49,000 people, sorry, 25,000 people working in 49 factories that maintain all the rolling stock in the French railways, including the high-speed trains, the TGV. Okay, and we've done a lot of work with them in dozens of their factories, but this one is their elite high-speed train factory, or one of the two. And the renovation of the trains were taking a lot more than 70 days initially. The train is a complete unit, right, with 10 to 12 cars and locomotives at each end for those who haven't ridden on a TGV, which I recommend if you haven't. Anyway, so the renovation, where you strip everything out basically and then put everything in new wiring, new functionalities, Wi-Fi, new seats and all this sort of stuff, was taking over 70 days. We got it down to 38 days, and at the same time we increased labor productivity by 20% and did some other stuff. Why do I point this out? For those who don't know what this kind of organization is like, there are very strong unions, and often people look at these sorts of organizations and say everything's impossible, right? Because of that. We don't see the problem. We've done that, and many other organizations such as those, and got extraordinary results. All you have to do is build a win-win solution where it's good for the shareholder, good for the management, good for the unions, good for the people, and off you go. That's what we did. We improved the working conditions, we improved a number of things, and there was absolutely no resistance to change. They went on to even better things after that. Okay, so that's a change in an organisation which many people have said had a lot of inertia. This one, European leader in designing and making satellites, came to us because there was a very important strategic defense satellite that was running extremely late, and they wanted to know if we could get it finished on time, because there was very important strategic and financial reasons to get it finished on time. And so we had a look, and indeed the first calculation showed we were going to finish very late, but we worked at it using the critical chain approach, and managed to more than reduce by a factor of more than 2 the duration of the end of the project, since we were recording right at the end, and it finished just on time, a day and a half or 2 earlier. I think it was a bit of a tight fit, that one, but that was it. And by the way, that one I put in because so many projects like that, people get into micromanagement. That satellite had, I believe, 5,000, certainly more than 3,000 tasks in the work breakdown structure, right? And they were trying to manage that many tasks, and it was not possible. So one of the things we did was we were implementing critical chain, was to simplify the model and get it down to about 200 tasks, and that was something that was manageable. Anyway. The next one, It turns out to be very topical, of course, because it's medical devices that diagnose respiratory infections. In fact, we started in March of last year, 2019, working on the development of machines that did diagnostics for respiratory diseases. Okay, and we implemented the critical chain then, and it all went fine. As you can see, yet another nice example of a development right in the fever charts. This thing here shows that there were problems. But it all went well, and the product was developed. And then, of course, COVID happened, and so they had to quickly adapt the testing machine so it could also include in its analysis COVID-19. They've done that, and so that's our implication with regards to the COVID situation right now is heavily in the diagnostic domain, trying to get more and more diagnostic machines and cartridges and stuff produced in the world. As you know, that is very important. Okay. Change of continent. The Mexican desert, a 1,000-person factory belonging to a large original equipment manufacturer in of French origin, and probably one of the, well, certainly the leanest factory I've ever worked in. And this organisation has been lean for a very long time. It started in the 70s, becoming lean, and the performance of defects per million parts and the SMED and OTED and all that were omnipresent. They were really very, very good. Anyway, they had been caught out by a sharp jump in demand for the car industry throughout the American continent, following the aftershock of Lehman Brothers, basically. And so suddenly they couldn't keep up with demand, and they were starting to stop nearly all, in fact, the manufacturers of cars in the American continent, since they produced over 50% of them. So there was a lot of tension in this factory, right? General Motors put them on new business on hold. I put that NBOH there on purpose because I make fun of people using all these complicated symbols and stuff and jargon, but so you couldn't possibly know what NBOH means. New business on hold. General Motors had said, if you don't deliver my alternators on time, I'm not going to give you any more orders. So it was fairly tight. There was a resident team from General Motors behind every machine, 3 shifts, and they had 11 plant managers in there, the best in the world, were all being brought in. Anyway, they'd done all that. It still wasn't enough. They were still stopping Detroit. So some brave fool in the management committee of this company, very, very lean, right, said, well, I guess we've tried all we can in the lean thing. Shouldn't we try theory of constraints? So off we went. We were sent off to this factory in the Mexican desert, not exactly welcomed because not from the right sect. Anyway, off we went. We did a quick analysis. Why I put the Russian dolls there is because the focus of the theory of constraints is like that. The problem between General Motors and this company was in Mexico. In Mexico, it was one of the autonomous production units. In one of the autonomous production units, it was one of the machines. In one of the machines, it was several. So this focusing mechanism between two big multinationals, the problem ended up being the size of a shoebox, right? Anyway. So once we found that shoebox, and we found it very quickly, we just said that machine must never stop. We buffered it correctly with a 12-minute buffer, and that immediately increased throughput of the bottleneck, and therefore the whole organization to 1,000 people by 17% immediately, or in 15 minutes. The time for me to explain what we needed to do, and off we went. And then we did other things, as much theory constraints and lean, and little by little we increased the output and productivity of the factory by 30% of the following months. And there you are. The tall guy down in on the photo there is our tallest consultant, Selim, right? You can see, and those are the alternators and stuff. If you want to see more, there's several videos about this case. Okay. And to finish off, again, change of continent, this time Africa, gold mine. a reputable gold manufacturer, a gold mining company, beg his pardon, and a mine in Africa with 2,500 people, already very active with a very good continuous improvement culture based on Lean Six Sigma. And they asked us to inject some theory constraints into this Lean Six Sigma culture, and that's what we're doing. This is an ongoing project, in fact. We decided to start by implementing critical chain on a certain number of subjects. Critical chain on all the planned plant shutdowns. I don't know if anybody knows what a gold mine looks like, but on the bottom left-hand photo there gives you an idea of a tiny part of the factory. It's big, and the machines are big and stuff, right? The plant is huge, and the shutdowns were already well managed, but they decided they could probably do them better and faster using critical chain. So that was one area. We've also implemented, or in the process of implementing, critical chain on the maintenance of all the mobile equipment, the trucks, the drills, and all the other stuff, right? You see that little. For those who haven't been in mine, that's quite a big truck, right? And that's a 125-ton load, that one. And we also doing some work on identifying the bottleneck. Is it in the mine? Is it in the factory? If it's in the factory, where is it? And all that sort of stuff. And while we were about it, we also had a discussion about their improvement portfolio, and I wanted to mention that because I think you'll find, well, we find it quite often. We looked at all the improvement actions that have been implemented over a year, and we just pointed out which ones were cost-saving initiatives and which ones had aimed to increase the throughput, increase the productivity and the production of this mine. Okay. And basically, it was 95% of all the improvement initiatives that have been carried out in a year were cost savings, and only about 10% had actually aimed at improving the output of the factory. Okay. Anyway, we discussed this, and I've done it with many of my clients, and it was quite easily agreed that in fact this was wrong, because when we looked at the return on investment, it was those few actions that had increased the throughput of the factory that really made a lot of money. The ones in the cost-saving category made some money, but less by a factor of 10. Okay, so we shifted management attention to spend more time trying to produce more and less on reducing waste. And I think that's something we find quite often, because people find a lot of tools that aim to reduce waste in the lean toolbox, and therefore they spend too much time doing those actions and not enough time doing projects that will increase sales, increase output in one way or another. And I mention that because I say that to a lot of people. Maybe it's your kids. Okay. And so this is going on right now, and of course it's being done remotely.